So we always start with a type of research question. Which type of research question should be answered by this one-way ANOVA? So in independent sample t-test, you learned about the difference of mean. If there is a difference of mean between the two independent group, and if you want to test, we apply independent sample t-test. Same concept is there in one-way ANOVA only. The only difference is here it is more than 2 group. So 3 or more than 3, we apply one-way ANOVA. So the research question will also be the same. Underlying assumptions are also the same as that of an independent sample t-test. The only difference is the number of independent groups, and the number of independent groups in one-way ANOVA, it is more than 2, that it is either 3 or more than 3. So if I want to see the difference between the average BMI score across various race. So in our data sheet, which has been shared to you, the race has been categorized into 3 categories: white, black, and others. So if I want to see the mean BMI score across these 3 groups, and if I want to test whether there any difference exists between these 3 groups, then I will apply one-way ANOVA. So here we can see that the mean BMI score is a type of continuous data, and the other variable, that is the independent variable, that is a categorical one, and the category should be more than 2. If you see the second example, you can see if I want to test the difference in post-operative pain score across surgical technique 1, surgical technique 2, and surgical technique 3, then I will apply one-way ANOVA. Here, the one dependent variable is the post-operative pain, which is measured on a VAS scale, and the independent variable is the categorical one, where the 3 categories are technique 1, technique 2, and technique 3. Third research question can be, does the student satisfaction level differs across various teaching technique? So the 3 teaching technique could be lecture, demonstration, and case-based learning. But here, the students are 3 different group of students. It is not the same group of students who have undergone 3 type of teaching technique. So that is the difference between a independent sample or a one-way ANOVA from the repeated measure ANOVA or paired t-test. We will see the difference. Here, please remember that in independent sample t-test and one-way ANOVA, the group of individuals should be different. It is not the same group. So that's why we learned that assumption of independence of observation. And that's why the term independent sample, because both the samples are independent. Similarly, in one-way ANOVA also, these 3 groups of students are different. They're not the same group of students who have undergone the 3 teaching technique. In that case, we will apply repeated measure ANOVA. That we will learn today. So is it clear to all of you up till this point about the research question, the more than 2 groups, the independence of observation? So in all these things, what have we observed? We have seen that there is a scale variable. The scale variable is the pain score, the mean marks obtained, or the mean BMI score, which is compared across a categorical variable, and the categorical variable has got more than 2 categories. So the appropriate statistical test for this would be a statistical test which can measure the mean of this across the nominal or ordinal variable, and the appropriate statistical test for such type of research question would be ANOVA, that is also known as the analysis of variance. So it is the analysis of variance, and it is also known as the between subject ANOVA, one factor ANOVA, and here we compare the means of more than two groups, and we perform the post hoc analysis. Because there are more than two groups, so there will be differences across group 1, 2, 1, 3, and 2 and 3. So for that, which particular pair is showing a significant difference, that we have to do, and we do it by the post hoc analysis. So just to understand this post hoc analysis, if you see this example, so this is an example. The kids plan to break their money bank, right? There are three types of money bank here. The question is, whose money bank has more money? And you have set a rule that if the amount is more than 500, then it will be considered significant. And I have assumed that all the money bank have equal amount. So this is situation 1. So situation 1, you can see in the first one, you have got 150 rupees, in the second 190 rupees, and in the third it is 250 rupees. Now seeing this, what is your interpretation? Whether this, once the kids have planned to open their money bank, whether the difference between these three is significant or not. Please type in the chat box. Remember that you have set a rule that if the difference, we have set a rule here that if the difference is more than 500, then it will be considered significant. So yes, Tapodev, Praveen, they are writing that it is not significant. Why? Because if you see the difference between 150, 190, 150, 250, and 190, 250, all these differences are less than 500. So that's why it is not significant. Coming to situation 2. Now see this situation and tell me whether it is significant or not. Pawan is writing yes. So yes, if you see the difference between 200 and 800, between 1 and 3, it is significant. Yes, Praveen is right. But between 4 and 8, it is not significant. And between 1 and 2 also, 200 and 400, it is not significant. But because of this 1 and 3, you will get an overall significance. But overall significant and post hoc, like significance between which two, that is important to know. That's why we do the post hoc analysis. Now you see this situation. Then can you comment on the post hoc analysis significance? Is it significant? Yes, Pawan is writing 1 and 2 and 1 and 3. Yes, you are right, but there is no difference between 2 and 3. So now you can understand the post hoc comparison. So here also you will find an overall significance, and when you analyze it, that which pair this significance is coming because of which pair, then you will see that it is due to the 1 and 2 and 1 and 3. Because the significance between 2 and 3, it is not, because it is less than 500 and that is 200. That's why it is not significant. And finally, this is the situation. So what is your comment in regarding this? Yes. So it is all is significant, because you can see that between pair 1 and 2, between 2 and 3, and between 1 and 3, all the differences are more than 500. That's why all significant. So that's the concept of post hoc analysis, and we will see such post hoc analysis in one-way ANOVA and in repeated measure ANOVA also. In chi-square also, we did this post hoc analysis where we put just adjusted standardized residual. When you saw that because overall chi-square significance tells you that yes, that association is significance, but that significant value is coming because of which pair, that we have seen that if the value of adjusted standardized residual is more than 2 between the two pair, then it gives you the overall significance. Can you recall that adjusted standardized residual, which we did in chi-square? Okay, so now we'll do the, so this is one example. You can see here that there is a group of male, there is a group of female, 5 male and 5 female. The frequency is 65 and 75, and the mean BMI is 18 and 26.4, 18.2 and 26.4. If I want to test whether this mean BMI differs across these two groups, which test should I apply? Please type in the chat box. Yes, so independent sample t-test. You're right. Now see this situation. Instead of 2 groups, now we have got 3 groups. Male, female, transgender. Yes, the frequencies are different. And mean is 18.2, 26.4 and 23.6. Yes, so for this, we will use the one-way ANOVA. So now in one-way ANOVA, we need to understand few concepts. Now we have seen the concept of variance yesterday. Can you recall the various data set which we have given you on the Mentimeter? Giving the example of 11 people, male and female, their mean systolic blood pressure, and was the variance was 0, near to 0 or far from 0? Can you recall yesterday's Mentimeter question? Where it was in one hypothetical situation, there was no variance. That means it was 0. In the second case, it was slightly above 0. And in third case, there was a variance. So the variance is basically the difference of the individual value from the mean. And if you total that mean, and that is the variance. Under root of that, we call it as a standard deviation. That's why square of standard deviation is the variance. So if you just apply that similar concept here you can say that there are 3 groups. Okay, so there will be difference in between the groups. So there will be between group variance, which you can see here, group 1, group 2 and group 3. So if the 3 groups represent the male, female and transgender, there will be the difference between the group, which is known as the between group variance. And now there is a variance within the group. So the variance within the group is the same which you did yesterday. Between the group variance means you take the mean of all these 3, take a overall mean and then subtract each overall mean by a group mean. The concept is similar. So there will be between group variance and there will be within group variance. Am I making myself clear to you? What do we understand by the between group variance and within group variance? Or should I repeat this one more time? Okay, so within group variance is standard deviation. Within group variance, when you take a under root of that, it gives you the standard deviation. Yes, you are right. So here, yes, Shruti is also, so people are asking me to repeat. So I'll repeat once again. So here you can see, what do we understand by variance? First, let's revise it. So variance is when you subtract the individual value from a mean and then take a sum of that and divide it by the frequency, that gives you the variance. If you take a under root of that, it gives you standard deviation. Are you clear up till this point? If yes, then yesterday we did one example where we saw the individual. If let me show you the same example once again. Then maybe. So this was the question. Variance of SBP across gender. So if you see this data, so now you can see here, there is an individual, there is an overall mean, and you can see these two values, male and this male, 120 and 124, 110. So there will be a group mean of this 11 people. And if you just take the difference of individual score from the mean, it is called the deviation. And when you square all the deviation and add it, we get the, variance. So this is the variance of this particular group. So this is known as the within group variance. Okay, you are taking the within group variance, means the variation from the mean or deviation of the individual score from the mean. So this was an example of within group variance. Now coming to the so now coming to this you can see here there are three groups: male, female, and transgender. So this tells you the mean of male, like you see the previous example. This is the mean of BMI of male, this is the mean BMI of female, and this is the mean BMI of transgender. Okay, if you take an overall mean, overall means 18.2 plus 26.4, 23.6, take a mean of all these three groups, and then you subtract, measure the deviation of this group mean from this individual group mean, and then square it. That is the between group variance. Are you clear now? Shruti and Praveen and the other people who are attending. It is just that between group means you are taking three mean as one one value, and then take out overall mean and then you subtract it. So I'm not going into the statistical part of it, but if you can imagine, it is just the between three groups, what is the deviation from overall mean. Overall mean means the mean of male, female, and transgender. Okay, so that's the between group variance. And within group variance is the same which we did yesterday, and I have told right now also, that is the within group variance. Variance means the deviation from the mean. That is a variance, right? So this too, the F statistics, basically we calculate a F statistics in the ANOVA with 2 degrees of freedom. You will see in the output also. That's why we have got 2 degrees of freedom, means there is 1 degree of freedom which is showing the within group, and there is a 1 degree of freedom which is showing your between group variance. Okay, because against that you have to take the p-value and the F statistics. So F statistics is the, in the numerator, it is the within group variance, and then in denominator, it is the between group variance. So F statistics is the ratio between two variances, F value. It is the F, like you have seen the T statistics, you have seen the chi-square test where the chi-square statistics was there. So in ANOVA, we calculate this F statistics. So ratio between two variances. It is the ratio between two variances. So it is a ratio between the subject variance and within subject variance. So the width of spread of group means the width of spread within each group. And under null hypothesis, we tells that this F statistics is 1. Okay. So now coming to the, there is another concept of variance which is explained to you here. You can see here there are three bell-shaped graph. Okay, can you see? There's a red, there's a dotted, there's a blue, there's a dotted red, and there's a dotted green. So these three, if you see these three, there is a low F value. Why? Because the between subject variance is low. So the three means are close to each other. So there is a low variability between the group, but the variability within the group is same. If you see the height and everything, all the bell-shaped curve are same. So the variability between group is low, but variability within the group is same for these three. Now focus on this graph. So here you can see there are three similar looking graph. Here you can see that within subject is same, but because within group, the three means are farther than each other. You can see it is 6, 10, and 14. Whereas if you see the mean here, it is 9, 10, and 11. So if the mean of the individual group is very close together, then the F statistics is low. That means because variability is low. If the mean of the three group are far, keeping the within subject variance same, then the F statistics is high or the variance is high. Did you get this concept? Did you understand this? Or should I repeat this concept once again? Please respond. Aliza is saying yes. Praveen is saying yes. Darshana is saying yes. Okay. So now I think I have made myself clear regarding within subject variability and between subject variability. And this F statistics is the ratio of these two values. Okay. Because you will, maybe in the advance also you will, I mean in logistic regression and in linear, there also we apply this ANOVA, and there, you know, it also gives you that F statistics. So the concept of F statistics is important here. Why? Because here there are more than two groups. That's why that concept of variance is important between subject and within subject. Now, if you see this, the assumptions are same as that of a independent sample t-test. In independent sample t-test, we read that the dependent variable should be continuous. In the research question, we have seen it, like the pain score, the BMI score, marks obtained in the exam. All these are example of the continuous nature of the data. And the independent variable should be categorical in nature. The categories should be more than 2 categories, and there should be independence of observation. Means I am reiterating it time and again, because this is the only difference. Only means there are many other, but this is a very important difference between a paired t-test and an independent sample t-test, and between repeated measure ANOVA and one-way ANOVA. Because in one-way ANOVA, you have independence of observation. Means there are 3 groups. Male are separate group, females are separate group, transgender is separate group. If you have counted one individual as female, you cannot count that individual as male. Means all the three groups have different set of participants. So that is very important to understand the one-way ANOVA and this independent sample t-test. The other underlying assumptions are the same as that of independent sample t-test, like dependent variable should be normally distributed in categories of the independent variable. There should not be any significant outlier in the dependent variable, and homogeneity of variance should be equal in all the three groups. So this we have discussed in the independent sample t-test. So I'm not going into the detail of this. We will just see here again the same thing. We apply the Levine test of equality of variance. If the value p-value of Levine test is more than 0.05, then we assume that equality of variance is assumed. We have done that in the independent sample t-test, because then we use, if the equal variance is assumed, then we use a separate different column of the t-value, that is a standard t-value, to report our result. If the equality of variances is not assumed, then we use the Welsh t statistics for the reporting our result. Same thing is applied here also. We'll see how. So the null hypothesis in case of a one-way ANOVA, that the population mean of the three group estimated from the sample mean is equal to known population mean. Here the population mean is not equal to the known population mean. This is the null and alternate hypothesis. Now again, the homogeneity of variance testing in SPSS, we test the variances of the population from where we have withdrawn the sample. So Levine test for this equality of variance, and it tests whether the sample came from the population with the same variance or not. Means they are representative of the population. Then only we can extrapolate our result over the population if that homogeneity of variance is met. So SPSS produces two independent type of F statistics. The first one, when the equality of variance is assumed, then we take the standard F statistics, we take its degree of freedom, its p-value, and we use Tukey's post hoc test. So just remember the name now. We will see how to apply this test. If the equality of variance is assumed, we use the standard F statistics like we did for the standard t-test, and we use the standard p-value, and we apply the Tukey's post hoc test. If the equality of variance is not assumed, then we take the Welsh ANOVA, like we took the Welsh T, its degree of freedom, p-value, and then we take Games-Howell post hoc test. So here you will, I'm introducing you with the two new name, that is a Tukey's post hoc test and Games-Howell post hoc test. Tukey's post hoc test results comes with both these values. It's you who have to take a particular value seeing your equality of homogeneity of variance, like we did for the t-test. So this we have seen that if it is not equal, we will use Welsh ANOVA and a different post hoc test, that is the Games-Howell post hoc test. So now coming to the example, if I want to study whether there is any difference in mean systolic blood pressure and mean cholesterol of patients across various BMI category, and the BMI categories are normal, overweight, and obese. So if I see the assumption, my dependent variable is the systolic blood pressure and cholesterol, both of them are continuous in nature, and my independent variable is the BMI category, and that category has got more than 2 category. Here it is 3 category. So coming to the data set. So this is the data set. I'll explain this data set before I go with the analysis. So you can see here, there's the age, gender, race, socioeconomic status, BMI category, systolic blood pressure, diastolic blood pressure. Oh, sorry, DBP is not there. Systolic blood pressure and cholesterol. And if you, this is again the same thing which we did, type of variable numeric, because not a single variable is a string. The width tells you the width of the string variable which we have not used. Decimal tells you the decimal place of the numeric variable. This label is the full form of your variable which you have written. This value is for the categorical variable. In this case, there are categories like socioeconomic status, race, and gender, but that coding is not entered here, which should have been entered. So you can again write it down, like 1 was for female and 2, although we don't have to do any analysis on gender. So, but again, because that data will be there with you. So this is male and I have added. So this you should add the labels. Otherwise, you will not, otherwise also it comes with the name if you don't label it. And then this gives you the missing, this columns gives you the width of the column, and this gives you the scale or ordinal. This role should be none, whether we have not changed it, ideally it should have been done. So there is an error from our side. So now coming to the data view. If you go to the data view, now two assumptions I have checked. So one assumption was the nature of the continuous data, that is, should be the dependent variable should be continuous, and the independent variable should be categorical with 3 or more than 3 category. Now I have to apply this normality. So for that, what I'll do, I'll go to analyze, I'll go to descriptive, I'll go to explore. So if you go to the explore, you are ready with this factor where there is a dependent list and there is an independent list. So here you can see, what should I do here? I should move the BMI category to the factor, because I have to see the systolic blood pressure and the cholesterol to this dependent, because I have to test this across this category. And I don't want statistics where we applied statistics. So if I want that mean, median, mode, interquartile range, trimmed mean, percentile, kurtosis, skewness, for that, I will click this statistics. But I do not want statistics now, because I assume that I have done it in the initial part of analysis. So I'll come to this plot. I'll go to this plot. I'll uncheck this stem and leaf. And check this normality plot. I'll press this continue. I'll press this OK. And then you will have this output. So if you see this output, now you see that it will give you a case processing summary. And then you can see the test of normality. So test of normality we did yesterday. There are subjective ways, there are objective way to assess this. The numerical way, there is a kurtosis, there is a skewness, and there is a Shapiro-Wilk test and mean and standard deviation. So in the Shapiro-Wilk, we did that if the p-value is less than 0.05, then it means that it is not normally distributed. Similarly, we have seen that the value of kurtosis and skewness should be within 2 plus minus. Kurtosis, we did it the peakedness of a graph, and skewness, it is the symmetry, whether it is a right skewed or left skew, that is measured by the skewness. So that we have seen yesterday. And then there are subjective way. In the subjective ways, we learned about the histogram, we learned about the QQ plot, that is the quantile plot. So in the QQ plot, because its sample size is more than 50, so it's better to use the QQ plot. So I'll come down and I'll see, this is again visual inspection of QQ plot shows that the systolic blood pressure across category BMI normal is normally distributed. This is again normal. This is also normal. If you see this BMI category across this mean BMI, systolic blood pressure across these three, then you can see what about the outlier. So that outlier, you can see that the outlier, this normal, overweight and obese. So can you comment whether there any outlier or not in this case? And if yes, is it a normal outlier or an extreme outlier, or in which group? So please type your answer in the text box, or you may unmute yourself and answer. Yes, so Pawan, Shamima, yes, overweight, 2 outlier. And it is a normal outlier. And it is the, what is 69 and 173? What is 69 and 173? It is the ID. Yes, it is important. It is the ID, not the value of this. It is not the value of systolic blood pressure. Yes, it is a serial number or ID. So that is important. So now what should you do with this outlier? We have read about the outlier yesterday. What to do with this outlier? What should be done with all outlier? Please type in the chat box. With 69 or 173 का मुझे क्या करना चाहिए? Include in data, ideally be retained, include. Yes, the first prerequisite is report it. Report it means you acknowledge in your result that you have found these two outliers. Yes. Now, what you'd want, you may remove these two, or even if like independent sample t-test, ANOVA is also robust. So with this few outlier, it is not going to make any difference in your result. But the most important is report the outlier, and then you can mention that either you have removed it or you have included it. That's up to you. But again, I have said it's better even if you include it, it is not going to make much change because the data set is large and ANOVA is a robust test. So few outliers, you can keep it. But the important thing, the bottom line is report the number of outlier in your data analysis that you have found this much of outlier. Okay. So then I'll come down, and this is the QQ plot of cholesterol. You can see it is linear, normal distributed. This is again normal distributed. This is the box plot of the box plot is for checking the outlier. So here, what is your comment? If you see the cholesterol level, please type in the chat box. In which group, how many, and type of outlier. Two normal, yes, two normal in normal category, yes. Okay. Praveen is writing 2 normal group, outlier, 2 in overweight, yes. Any extreme outlier in any group, or all are normal? One extreme, yes, that is 187. Priyanka is also writing. Darshna, Tapodev, yes, all of you are right. Praveen, yes. So now I think you have understood the concept of outlier. You have understood that that was one of the very important thing which we should test before we go for the analysis. So you have checked for it, and now you have decided that your data is fit for analysis. One more thing, that is the equality of variance that comes with the SPSS statistics. So once you apply the command of one-way ANOVA like you did for the independent sample t-test, there only this Levine test of equality of variance value comes. So then you should go to the analyze. Now I can apply ANOVA. I'll go to the compare means, and I have to press this one-way ANOVA. Right? We did yesterday the one sample we did independent sample, then the one-way ANOVA. If you press this, again you will have a dependent. So you can move these two together in the dependent list, and the factor, again BMI category. And in the BMI category, you can see here that if you come to this post hoc you have to click. So we read about the two keys when the equal variance is assumed, and if it is not assumed, then you have to click this game solver, because this you will come to know only after that output is released. So you need to check these two beforehand. So that's why I have checked both these game solver and this LSD, this two keys. So now I'll press this continue. In the options, I want descriptives. Descriptive is because I want this mean value of all the three values. I want this homogeneity of variance, and I want this Welsh. So, tick alternate one. The first, leave the second, third, then leave the fourth, and then fifth. And then mean plot, it is up to you. You can click it and then press continue. So you have to only use this post hoc and options, and then press this OK, and then you have got this output. So now just focus for a few minutes here in the output. In the output, you can see that there is this is the sample size, this is the mean, this is the standard deviation, and then if you come to the equality of variance, here you can see the value of Levine statistics. So Levine statistics, the significant is 0.343 for systolic blood pressure. So that means equality of variance is assumed because the p-value is less than 0.0, it's more than 0.05. What is your comment regarding cholesterol? Is the equality of variance assumed, met or not met? Please comment. So not met. Yes, you are right that equality of variance is not assumed in the second case of cholesterol because the p-value is less than 0.05. Now coming to the result, the mean value. So if you see the mean value, you can see the mean difference. The month 137, 145 and 153. So these are the three different mean with standard deviation and the confidence interval. So if you see the value of ANOVA, so this value of ANOVA, it will give you so it tells this is significant. This is the F statistics. So this ANOVA is significant. Here also it is significant. Now we will see which to take. So if you come here, this is the Welsh statistics. So for cholesterol, which value you should take? The Welsh ANOVA value or the standard F? So here, because we have seen that for cholesterol, here you can see that the cholesterol is equality of variance is not assumed. So I'll take this value for my Welsh statistics, this one, the lower one for the cholesterol. Why? I'll take this degree of freedom and this statistics to report my result because that equality of variance was not assumed. And if the equality of variance was not assumed, I have to take the value of Welsh ANOVA. Similarly, for the systolic blood pressure, since equality of variances was assumed, I'll take this value to report my result because this is the standard ANOVA value. So is it clear to everyone why we are taking the standard ANOVA for systolic blood pressure and Welsh ANOVA for this cholesterol value? Is it clear to everyone? Repeat. Priyanka want me to repeat. Okay, Priyanka. We discussed in the theory that if the equality of variance is assumed, then we will take the value of standard F statistics, like we did for the T statistics yesterday. Remember the same concept. if the equality of variance is not assumed, then we'll take this Welsh ANOVA value. So if you see here, if you go above, you go here, and if you see the value of this Levine test of equality of variance. So now you have to answer me. So Priyanka, this systolic blood pressure, what is your comment? Seeing this significant value, is the equality of variances assumed or not assumed? Please answer. Either you can unmute yourself and answer, or you can type in the chat box.
Since it's significant, so it is not assumed.
Can you repeat once again?
Ma'am, this is significant 0.343.
So variance assumed or not assumed?
So ma'am, it is not assumed.
No. So that means you missed somewhere in the lecture.
Yeah.
I've told you in the theory that equality of variances assumed when the p-value is more than 0.05. We did this yesterday also. If you can recall yesterday lecture, we did this yesterday also, because the null hypothesis states that the equality of variance is there. So that's why we don't want p to be significant. There are few situations where we don't want p to be significant. The one was Shapiro-Wilk, where we don't want p to be significant. The second is this Levine test statistics, where if it is non-significant, it is favorable for us. So here the value of this significant value is more than 0.05, isn't it? 0.34 is more than 0.05. That means this is not significant. That means that equality of variance is assumed. Don't go by the significant and insignificant. It only depends on the null hypothesis, whatever you are saying. Significant value doesn't mean that the equality of variance is met. No, it's the other way around, because this significant, remember, it depends on the null and alternate hypothesis. Let me connect it to the charger because my laptop is now. Just a sec. So now, if you see this, so is it clear to everyone? Pawan, Priyanka, Aliza, and all Praveen. So if this is not significant, equality of variances is assumed. Please remember this. This is here the p-value. We don't want this p-value. Okay, so this is not significant. That means equality of variance is assumed. Now, we studied two things. If the equality of variance is assumed, then we will use the standard F statistics. So in the output, you will see that we see both type of statistics. There is a standard ANOVA. This table is for the standard ANOVA. And if you go down here, can you see something written here as Welsh? You can see here now. Can you see these two Welsh? Okay. So this Welsh ANOVA is the ANOVA value, the F statistics value. When the equality of variance is not assumed, then we take this Welsh ANOVA value. Okay. So now the two table, this ANOVA is for the standard ANOVA. This ANOVA is for the standard ANOVA. This one. This is the standard ANOVA. So this output SPSS gives you both the values. Now you have to decide based on this Levine test statistics value, which ANOVA you have to take. Whether you will take standard ANOVA statistics or you will take Welsh ANOVA statistics. So now, because for systolic blood pressure, you can see it is not significant. Not significant means I will take standard ANOVA value, this value, right? I will take this degree of freedom and this F statistics 3.6, and this significant level. But for cholesterol, I cannot take this. Why? Because for cholesterol, you can see that the equality of variances was not assumed. So I have to take this Welsh ANOVA. And which row I will take? So I have to report this value. Is it clear to all of you now? Please say something, then only I can move forward. Otherwise, I'll repeat this concept once again. So don't confuse this with the Levine statistics case significance go. You cannot, equate it with the significance of ANOVA, because Levine statistics ka significance, I've told you that null hypothesis is different. That's why we don't want p-value to be significant. The similar case was there with the Shapiro-Wilk. Shapiro-Wilk, I don't want my p-value of Shapiro-Wilk to be significant. Why? Because I want my data to be normal. So remember these two cases, and there is one more we'll discuss again. So Levine test, Shapiro-Wilk, p-value, if it is more than 0.05, it is good for us. Okay? If you don't want to remember the concept of null hypothesis, that is fair enough. Don't remember. But remember that we don't want p-value to be significant. Everywhere we want p-value to be significant, but for Shapiro-Wilk and for Levine statistics, we don't want p-value to be significant, because if it is not significant, then it will say that the data is normally distributed in case of a Shapiro-Wilk, and the homogeneity of variance was met in case of a Levine statistics. Is it clear to all of you up till this point? Then I'll go further in the post hoc, because post hoc also we have read that if the Levine if the homogeneity of variance is met, then we will use the which post hoc? Tukey's post hoc. So now coming to the post hoc, and if now again see
one question. In Welsh statistics, we are not getting statistics related to between groups and within groups, like in standard ANOVA we are getting. So how are we going to report this in paper? Like usually in paper they write like F2, 45.
No. See, it is there in the Welsh also.
Where, ma'am? Within group, between group. Okay. This DF1, DF2, right?
Yes.
Okay. But it's strange. Okay, ma'am.
So now you can see this multiple comparison, right? So now it gives you both the values, like the values of this Tukey's as well as the Games Howell. Why? Because if the homogeneity of variance is met, then you will take this one, the Tukey's. So in case of a systolic blood pressure, what should I take? I should be taking this, because in case of a this one, right? And in case of a cholesterol, I'll take this Games Howell. Did you get this? Now, I have not gone into the interpretation now. Just a second. Don't get frightened by this huge look of the table, right? You have to focus only on up till this. I'll show you, only focus on this for the time being. Let me move this again to the upper. This is creating problem. Right. Yes. Yes. So can you see this? So if you compare this, if you see the significant level, first focus on this significant. So which value are significant? It is 0.024, 0.024. These are the only. So which pair? The difference between normal and obese. The difference was in the systolic blood pressure was of 15 millimeter of mercury with the significant level of 0.024. The lower and the higher is 229.91 to 1.65. Since both these are having the same sign, it is significant, the confidence interval. Okay. The other pairwise comparison is not significant. So I'll look only for those pairwise comparisons. So this is same 0.024. This has done the normal minus obese. Whereas if you see the obese minus normal, it will give you the positive one. It is only the from which value you are deducting which value. That's why these two are same. This 15.75 and this 15.7. The only difference is the minus sign, because in the first one, it has done the normal minus obese. In the third here, it has done the obese minus normal. So can you see this? All of you, and can you appreciate this? Or should I repeat it once again? If you just focus on this pairwise comparison, I've told you, first focus on this significant level. So for significant level, I am focusing on this. Okay, I'm not focusing on Games Howell. Now just bring your attention only for this column. In this column, which value do you think that it is less than 0.025, 0.05? Yes, please type. In the text box, please type in the chat box. Yes, 0.024, it is okay, but it is between which pair? Because we are doing now post hoc. Normal and obese, yes. And did you understand why why in one row this is minus and here in the other row it is plus? Can you see? The values are same. The only difference is minus and plus. So can anyone explain this? Praveen, can you explain this for me?
Yes, ma'am.
Someone is writing, same with reverse. Yes, Praveen,
Yes.
you may unmute and answer.
Yes, ma'am. In the first one, it is from normal to normal minus obese. It is compared between the normal and obese. So it means they have might subtracted obese value from the normal value. So it is coming minus. In the lower ones, normal value has been subtracted from the obese value. So it depends upon the which value is higher value and which value is lower value. And depending upon that, we are getting the minus or positive.
Yes, you are right. So now all of you, did you understand this concept of post hoc? Did you understand this? Or should I repeat this once again?
Ma'am, can I say something?
Yes, yes, please,
Yes, ma'am.
please.
Like, just I want to see whether I'm asserting it right or wrong. If
Yes,
I
please,
say that
Ashish.
if we are using ANOVA, we will get to know whether there is difference between the groups are significant or non-significant. But we are not able to see in which respect they are significant. So that's why we are using post hoc. So when
Yes.
there's I minus J, it means that it's showing mean difference between one group with respect to the mean difference with respect to other group. Is this correct, ma'am?
Yes, yes, you are perfectly right, Dr. Ashish.
Okay, thank you, ma'am.
So if at least one pair, here also you can see that one pair is showing the difference. No, not all the pair. Like we did for that kids piggy bank. Remember, there if one group, even if one group is showing a significant difference, you will get an overall ANOVA significant. Okay. Any other question up till this point? If it is okay, then I'll go for this cholesterol interpretation. If not, then I'll go to the cholesterol because I have to use this Games Howell. Why I'm using this Games Howell? Anyone? Please tell me.
Ma'am, because variance is not equal.
And why? How can you say that variance is not equal?
Ma'am, on the basis of living statistics.
Okay. And what should be the value of Levine statistics?
It should be it should be greater than 0.05.
Yes, yes, Ashish, you are right. Praveen is also right because the variance was less than 0.05 in that case. It was 0.000. If you see the cholesterol, I'll show you once again here. We can go up and we can see here the value of this was 0.000, which is telling us that equality of variances not assumed. And we did that if equality of variance is not assumed, then we have to take the value of Games-Howell post-hoc test, and I will focus on this significant value. Now, can anyone tell me from this participant group which two groups are significant here in case of a cholesterol by just seeing the result? Please type in the chat box, or you can unmute yourself and answer.
No, ma'am, it is normal to overweight and normal to obese, but not between the obese and overweight.
Yes, yes, you are right. It is between the normal. So if you focus on the first column, you can see it is between the normal overweight and normal and obese. You can ignore the minus sign, or you can take the down one. So it's better that you start with the lower this thing, because here you will find the positive one. So if you focus on this, these two, so take the lower this thing of both the value. So you should start with the lower row. Why? Because the lower row gives you the positive this thing, because it subtracts the higher from the lower, and then you can take this overweight and obese, this one. So obese, normal, obese, overweight, you can take this, and then you can take this one value. This one. Am I audible to all of you, or any problem from my end, from our end? Okay. No, okay, that means everything is okay. So you can see that you can take both the two values of the lower row and first one from the middle row, because it gives you the positive one. So you can see that there is no difference between the overweight and obese, but there was a difference between the normal and overweight and normal and obese, the value of cholesterol in the post hoc analysis. Okay, so if you go down again, you can see that this gives you the mean plot. Although we don't report the mean plot, but that mean plot is there. So basically we report up till this point, post hoc, right? So now how to interpret this result? So coming, because this you have interpreted it here, now to how to write it, that we'll see here. So this was the question. I'll just reduce this size and I'll move this. Although this table is a bigger one, so again, but never mind. I'll go up. And here you can see. So I have entered the value. This is the BMI category. This is the mean systolic blood pressure, mean value, the standard deviation. This I have taken from this mean value, and the standard deviation I have taken from this column. Then the statistical, you can take the F value. So I have taken the F value as the standard F, and standard F, if I go down, then this is the standard F. F statistics, we report it with the 2 degree of freedom. So I have taken the value of 3.6, and then I have taken the degree of freedom 2 and 190. So you can see now there are 2 degrees of freedom. Because why there are 2 degrees of freedom? Because the 1 degree of freedom is between group. So the between of, there are 3 groups. So 3 minus 1, 2 degree of freedom, it will be with the between group, and this 190 is the degree of freedom is the within group. So this comes this, we have reported this result, P value and the F value. Similarly, if you go to the systolic blood pressure, the pairwise comparison, you can see that we have given the mean difference of normal overweight, normal obese, and overweight and obese. These are in the negative sign, but you can make it positive Ideally, you should make it positive. Just to show.
I want to ask one more thing over here. In this pairwise comparison of mean systolic blood pressure across BMI categories, in the pairs, why have we only reported these pairs? Why not other pairs too? Are we going to report only the ones which are significant?
No. We have reported all the 3 pairs. Is there any possibility? 6 pairs. There were only 3 pairs. Normal. What other possibility of pair can you think in this case?
Like obese, overweight. Okay, overweight, obese.
That is there?
Yes, ma'am. Okay, that's why.
Actually, the 6 pair which you have seen, that is only you only have answered, na? That is the lower minus higher or higher minus lower. You know, software doesn't know कि lower से high करना है कि high. It takes all the 6 into account.
Okay.
If you write normal overweight or you write overweight and normal, it is just the reverse of the sign.
Okay.
Did you get that?
Okay, so we don't have to take all of them.
No. Why will you take it? It will just be a repetition.
Okay.
So that SPSS gives you, but you have to, because the pairwise comparison is same. Whether you deduct normal SBP में overweight का minus करो या overweight में normal का minus करो.
Okay.
Value तो same ही आएगी. The only difference will be the sign. So sign के लिए I don't need to give the 6. No, it is not needed because it doesn't make sense also. The software is doing it because the software doesn't know कि कौन सा हाई है कौन सा लो है. हो सकता है कोई ऐसी स्टडी हो जिसमें तुम्हारा सेकंड वैल्यू लो होगा तो ऊपर वाला नॉर्मल माइनस सेकंड वैल्यू विल बी पॉजिटिव. Here the outcome, it depends on the outcome, positive outcome or negative outcome, right?
Yes, ma'am. And ma'am, one more thing, on the basis of seeing the confidence interval over here, can we comment whether it is significant or non-significant?
Yes, that's why you see that we have not included the p-value here. You can say there can now you can comment it is 19.3 to 4.3. So is it significant or not significant?
Ma'am, 0 is coming, so it will be non-significant.
Yes. What about normal and obese?
Again, non-significant.
No, but both are towards the same.
So negative. Yes, ma'am. It's going to be significant.
Yes, it is significant. What about the overweight and obese?
Non-significant.
Why?
Ma'am, 0 is coming.
Yes, because minus है 0 and then plus. So 0
Yes,
is coming in between.
Yes,
That's why it is not significant. Means one interval is towards negative side and the other is towards positive. So both should be towards the same side, either more than 0 or less than 0, then it is significant.
Yes, ma'am. Thank you, ma'am.
Okay. Other participant, did you get these, query and the answers of your query? Or any ambiguity or any confusion is there, then we would love to answer that. Please say something, Aliza, Priyanka. Okay, everybody is saying yes. So if you're saying yes, then now I would request one of you to read the interpretation, although we have discussed about the interpretation, but again, I'll make it. Yes. So can you read this? Anyone? Priyanka, you can do that because I am seeing your name now. So you can read that.
One day ANOVA was conducted to determine if the systolic blood pressure was different for groups with different body mass index, BMI levels. Participants were classified into 3 groups: normal in 82, underweight 71, and obese 40. Data is presented as mean plus with standard deviation. Systolic blood pressure measurement was statistically significantly different between different BMI categories, with the degree of freedom 2 and 190. F value with degree of freedom 2 and 190 is 3.6 and p value is less than 0.0029. Systolic blood pressure increased from the normal 137.8 with SD of 33.1 to overweight 145.2 with SD of 29.9 to obese 153.6 with SD of 28.2. BMI categories in that order. Turkey post hoc analysis revealed that the increase from normal to obese, that is 15.7 with CI of 1.6 to 29.9, was statistically significant with p-value of 0.024, but no other group differences were statistically significant.
And what have I missed out in this result? You have to comment now on that also. Did I mention anything about the normal distribution?
Normality, huh?
Yes, that is missing from this result. So that should have been included, because
Yes.
you saw now there were 2 outliers. So you found 2 outliers. Yes. So that 2 important assumption is missing. So before I write that one way ANOVA was conducted, I should have written a normality test across the various category of BMI was run. The visual inspection of the QQ plot shown that it is normally distributed, and the box plot has shown that there were 2 outlier in the overweight category of this systolic blood pressure. Remember, we saw 2 outliers, which was kept in the analysis. Right? That should be mentioned here. It is an error from our end. So that should happen. We will rectify this, right?
So, ma'am, is there any specific sample size or a number of samples that we should have to apply ANOVA? For example, if we have a very small group of, let's say, 35 or 40, so is it, can you apply ANOVA even in that?
Actually, they say that even if it is sample size, like if it is more than 6 in each group, more than 6 means at least one group should have, because there will be unequal arm will not be equal. So you can apply that. Ideally, we say for any parametric test, the minimum sample size should be at least more than 30. So if it is more than 30, and if in one group, even if it is more than 30, and in one group, if you're 5, like if there is a male, female, transgender has 4 sample, and the male, female has other samples, then ideally you should not apply, because at least 6 people should be there in one arm to apply both the independent sample and ANOVA. That is the criteria.
Thank you, ma'am.
Anybody, any other query?
Ma'am, over here in the interpretation, Turkey's post-test analysis revealed that there is increase from normal to obese 15.7, 1.6, 29.9 in the confidence interval. But in the table, like there was a minus sign in 15.7.
Yes, I said it in the beginning only that it should have been in the positive sign. So I should have written it like, I'll do it now. See, I'll delete this minus normal and remove this sign. And I'll add this minus here. Plus here. Similarly, I'll do this obese minus normal. This I'll remove. And I'll remove this negative sign because now everything will be in positive. And I'll do this obese minus overweight. I'll remove the sign also, and I'll change the So is it okay? Ideally should have been like this. Okay.
Yes, sir.
Because it was a mean difference. So maybe it'll be difficult for the reader to understand. So now it seems okay because it is in positive, and you can see it is the difference of overweight minus normal, obese minus normal, and obese minus overweight. Right? Any other query? So this is the same across the cholesterol. You can see that the cholesterol again, please remember that just reverse the sign. I'll do it, maybe not now, but I'll do it till the time you people are in the breakout room. I'll change this, right? This is again the same. Here you can see that the all the group are significant. So that's why star mark is in both. There are two groups where there is a star mark. And you can see here that we have written the value of Games Howell here. Games Howell post hoc analysis. We have not taken the two keys. And that value only you have to include here. Is it okay for everyone? Any other query before we go for the breakout room? Here also you can see that we have taken the value of Welsh. Can you see this? This is the Welsh F, right? If I have written Welsh in front of F, that means that Levine statistics assumption of equality was failed, right? So that you should do. And I think can we break for the breakout room if there's no other participant, no other query from the participant?